Okay, Bismillahirrahmanirrahim. So, this is our group F1, which is we are going to present our PBL 5, which is power factor with harmonics. So, my name is NABILAH, and uh, um, with my team member, which is AHAMAD, AZHARI, AZMI, and akmal IRFAN. So, in this project, uh, people use energy every day to do a variety of tasks, including providing service, producing goods, and providing comfort. A significant amount of energy is consumed, so they use electricity 24 hours a day, 7 days a week as a consumer. As a result, consumers employ a wide range of devices. So device may be linear or non-linear in nature. So non-linear loads, on the other hand, have the currents that is not proportional to applied voltage. All power systems have some degree of harmonic distortion. So computers, fax machines, printer, PLCs, refrigerator, TV, and electronic lighting blast are some examples of nonlinear loads that can generate harmonic current. So for the objective project to create a power system with fewer potential problems, to improve the efficiency of the distribution in power system, to address and control the effect of harmony in power system. Okay, next we continue with our result. Okay, so this is the result that we get. So this is the figure that shows instantaneous waveform of the source current before mitigations. So this is the list of FTP analysis before mitigations. Okay, as you can see, this is the data that FTP analysis uh, after we simulate it. So before mitigations, 46.63 percent at this setting, and the power factor is 0.7603. Okay, and then okay,
Okay,
this is
so
the
from this,
instantaneous
I
waveform of
will.
the source current after mitigations by adding series specific filter, and then the power factor that we get is 0.8001. Okay, so this is the list of FTT analysis after mitigation by adding series specific filter. So this is the result that we get, the list data after simulations, and then this is the graph or FTT analysis, which is signal analog uh, versus time. Okay, next.
Okay, so from this, I will continue. So I will can I will continue from the Aina Nabila, which is THD and the power factor before the mitigation with the various firing angle. So in this table one, we can see that when we increase the firing angle, so the THD will become increased, which from the 29.89 to the 46.63, while the power factor will become decreased, which is 0.9969 to the 0.7603. So table 2 is THD and the power factor after mitigation with various firing angle. So in this table, we can see the firing angle. When we increase the firing angle, so the THD will become increased while the power factor will become decreased. So next this is a plot graph between the THD and power factor against the firing angle. So we can see the the value is total harmonic THD is inversely proportional to the power factor when we increase the firing angle. So next, this is THD and the power factor against the firing angle after mitigation. So this is also same. When we increase the by firing angle, so the THD will become increased while the power factor will become decreased. So in the figures 8 and 9, so we can see both the image as that the firing angle increase, so that's the total harmonic distortion and the power factor value. So in figure 10 and figure 11, so THD versus power factor before mitigation and after mitigation. The pattern in both graphs are the same. The power factor has inverse relationship with the overall harmonic distortion. So the THD diminish as the power factor value rise. So from this, we can also deduce from this graph that the total harmonic distortion has an effect on the power factor values. So on discussion, okay. So in this discussion, we need to provide the power factor adjustment and harmonic mitigation in two ways, which is we need to eliminate harmonic in this project, which is we choose the to use the passive filter, which is made up of inductor and capacitor, and this is LC filter. So the non-linear load harmonic cause reactive power distortion which reduce power factor. So the power factor will fall due to the harmonic. So in the figure 4, the instantaneous waveform of the source current prior to the mitigation, the harmonic altered the waveform prior to mitigation with a THD of 46.63% and a power factor of 0.7603. So in addition, as indicated in table 1, there are few possibilities for the power factor value with the different firing angle. So if the firing angle is reduced, so the power factor rise over 0.8, which is a consider high a power factor. The total harmonic distortion lowers as well. As a result, the power factor will be good when the harmonic are lower and at a lower firing angle. So to improve the harmonic, a series passive filter was added to the three-phase thyristor rectifier using a universal bridge circuit. So the total harmonic distortion was reduced to the 38.83%, where and the LC filter was installed, and the power factor was 0.8001 at the firing angle of 45 degrees. So from this, we can conclude that when the firing angle is increased, so the overall harmonic decrease, also the power factor decrease. Furthermore, we prefer series passive filter over a shunt passive filter because a series passive filter will block the source harmonic current and generating spike in the source current. Besides, a low impedance in a shunt passive filter will cause harmonic to develop whereas the series passive filter has a greater impedance. As a result, utilizing a series passive filter is more effective than using a shunt passive filter in minimizing the distortion of the waveform of the input current. That's all.
So for the conclusion, so the total harmonic distortion is measured is by the explain of the voltage or the current distortion is caused by the harmonic signal. So it consider the audio, tone communication, and power system. So when the harmonic distortion enters a power system, its capacity to function at peak level was affected because of the increasing demand of power. It also caused the inefficiency in equipment operation, which is increases in overall current required installation and utility costs, increases handling costs, and reduces profitability. So harmonic in the system can raise RMS value of voltage and current. As a result, operation failure of filters and circuit breaker is possible at any time. That is one of the reasons why filters are essential in a system. So filter can either enhance or block specific frequency, resulting in a smooth sinusoidal wave at the end. It might be active or passive in nature. We are utilize a passive filter that is series filter for its PVL. So in the conclusion, We meet the goal of this PBL, which we were able to conduct analysis of the influence of harmonics on power system as well as investigation of the use of series filter to minimize the harmonic. So at the end of this PBL, we can infer that total harmonic distortion is inversely related to power factor. The power factor improves as the total harmonic distortion decreases. So there was a mistake while using the circuit, but we were able to solve it by performing some internet study.